Okay, good morning and welcome to today's panel discussion on how important is inline X-ray in factory automation. High volume manufacturing and high reliability applications have been increasing in automotive and medical and various other areas of technology, and all of that is driving the need for inline X-ray to work in real time. Up till now it's been used for sure, but in some cases the quality hasn't quite been there, but nowadays we are here to discuss some of the improvements that have come down the track recently to help X-ray work in the factory. Joining me today to discuss this on my far right, we have Michael Ford from Aegis, we have CK Park from Tech Valley in Korea, and we have Greg Wood from Nordson Matrix. So welcome, gentlemen. I'll get right in with my first question. Inline X-ray till now has been limited to a few high-volume product markets. What new applications are driving the expansion of inline X-ray? Shall we start with you, CK?
Oh yeah, definitely inline application means inspection of entire production. There is two important things. One is entire inspection, and second is without any human interaction during the process. So I think the most driven application area is automobile electronic boards. So this is very important for human crisis. So the perfect product is required.
Okay.
So I think the electronic boards, especially in Europe.
In Europe, yeah. Okay. Are you seeing any new markets opening up for inline X-ray?
Yeah, either in inline X-ray or semi-automatic X-ray. It's a semi-inline X-ray, and to me, it's really interesting on what happens outside of the traditional SMT line, where we're really seeing a tremendous drive for our products, for example, is in semiconductor package inspection prior to placing the package onto the printed circuit board assembly. We're also seeing a tremendous pull in the power hybrid segment. We're also seeing on the other side of the line, we're seeing drive in final assembly and test, battery inspection prior to installation into a mobile product. So the things that are the technologies that we're developing for, in some cases, much finer geometries, much more difficult inspection tasks that are being leveraged back into the more traditional SMT assembly line is really kind of interesting terrain right now, and it's really driving the lion's share in some cases of our business in terms of our technology development.
Right, yeah. I mean, Michael, with the miniaturization that's coming into the industry and the increasing requirement for reliability, do you think that inline X-ray is going to become a mainstream part of the line in the future?
Yeah, really it is. I mean, I'm a software guy, so, we can do wonderful things when we get data. And the ultimate goal of getting the data live as the line operates is that goal towards zero defects. Now, originally, kind of inspection machines were there as a filter. They would filter by discovery of defects, and those defects would then go off to repair. That's almost like a sad story, because it means you've already created a problem. Today's machines, they are not looking for defects.
Yeah.
The data is being measured to see what is the success rate of certain features that are being installed, so that you can use predictive analysis to avoid defects from happening by the feedback of the data that you get from the inspection machines, and utilize that to modify the process. The thing about X-ray is that it gives you the real view. You cannot get any better view of what you're looking at. The difficulty is in the interpretation of what you're seeing, because as the line is working very fast, you need real-time feedback. So getting the data from the machine in a standard format where software can start to work on it gives that software the opportunity to contribute towards zero defect for that line. Yeah. This is an incredible value, and it completely changes the value proposition of buying an X-ray machine. It's not a filter of something you've done wrong.
Yes.
It's actually the opportunity to do things right first time, every time.
So you're, in that case, it's going to be positioned in a line. In that case, it's going to be positioned before the reflow oven.
You can put it anywhere you like. It depends what you're looking for.
Once you bake these components onto the board, you're into money. So it's an interesting argument, but I totally take that on board. Now, as I said at the beginning, CK, the history of inline X-ray wasn't wonderful, frankly, but the technology's come on a long way recently. What things have changed to make it a really valuable tool now
unfortunately, although the inline and perfect inspection you said is filtering is required, but there's still have some two bottlenecks. What is the important thing is the cycle time required by a production floor. So far, the current technology couldn't catch that technology. So instead of that, most of customers is using large volume batch processing. So this is the main. And then once we overcome the cycle time, then the next issue is the accuracy, false call rate. How we can reduce the false call rate, which can be effective in production line. So that currently some the best technology, laminograph or computed tomography, of course, can do the perfect filtering, but we have to overcome the cycle time. So we need a new level of technology which can overcome these two things.
Right.
Let me just help you with that. Because having the data about the whole production process into machines means that you can understand which machines need to be inspected and which do not. So this leads into a whole area of adaptive test or adaptive inspection. Because you could have a longer cycle time than the line, but if you can identify any of the products that have come along the line for which there was absolutely no change whatsoever in the process, you could say statistically that you don't need to X-ray that board. Whereas any board where there was an experience of anything changing, like a reel was changed, or a setting was changed, or there was a long gap in production, anything, or even the paste on the stencil, there was some kind of aging of that. Whatever you determine to be a kind of significant change, you can flag that product for test. So it means that you can do, statistically speaking, you can do as good a test as testing every single board, but without the concern of the cycle time, because you are smartly selecting which products you need to inspect. So people have statistically proven that to be true.
I can see how that would help for sure. But I think CK, you've got a unique technology for being able to reduce the false call rate by analyzing data at the edges. Can you explain that a little bit to me? Because I don't know how that works.
I think I have proven data that with our recent artificial intelligence platform technology, which is proven by Samsung 5G product recently. The Samsung is producing 5G product already, and they are going to extend their production lines 2020 in a very large volume. So we tested our technology, and it is a problem. We reduce the cycle time 70% more versus the existing level. And we achieved the false call rate less than 3% by 5G board. So of course, the false call rate and accuracy and speed is depend on the product and application-wise. It's vary. But I can say that one best practice case is what we have done in Korea with Samsung. So I can.
Interesting. Really interesting. So, Greg, I mean, obviously a lot happening in the development of equipment. What has been happening on your platforms to improve the quality of the inspection and the throughput?
Yeah, sure. If you talk about the go all the way back to the hardware, I mean the image chain and the hardware that's used to create the images, there's been a tremendous amount of innovation in both the tube technology and the detector technology. And I'll go back to an example I used in the semiconductor side. So, for example, on a semiconductor defect, we may need 10 micron resolution. Now, we may not require that 10 micron resolution for a printed circuit board assembly. today, but instead of using a 12 millimeter field of view that we'd use in a semiconductor image, we can get the same image quality at 10 micron resolution over a 25 mm field of view. So it's really taking the technology that's developed for much more constrained and much more detailed inspection tasks, and then porting it back into the SMT side. To get further to CK's point, I think there's as much data out there that we don't use that we do use. And I'll use the example of a verification station. So an operator is typically making a decision at a verification station was it really a defect, or is it a false call? And it's easy to press that false call button. Well, there's a lot of things you can do to kind of make sure that the operator's band of decision making is really narrowed down. So for example, if it's clearly a defect, if there's a missing component, if it's completely misaligned,
right,
you don't want to even put that decision into the hands of the operator to make that decision. But I think more importantly, in terms of machine learning, there's data collected there, and each time an operator makes a decision that something that the machine called a defect is indeed a defect, there's data collected. We collect it in what we call a defect catalog. Now that information can sit idle, or it can be fed back into the system and used for either selecting which measurements you're going to take on the next batch of product that runs through. So I think, again, it's easy to kind of drift all the way to the end and say, we're going to take the operator out of the verification process altogether. Certainly, that's an admirable goal, and we should be driving in that direction. But for me, the real innovation in terms of product that's going to happen over the next 2 to 4 years is really centered around the machine learning that's resident in the system itself. And again, smart algorithms, tuning the machine automatically based upon the data that's collected. So I think the combination of a smart machine that is self-healing, if you will, or uses machine learning in an intelligent way, and making more tools available to the operator at the verification station to make it easy for them to make the right decision. I think really that's the bulk of the work, and too often the conversation drifts all the way to the end of this artificial intelligent environment where the operator comes out of the process altogether, and truly based on millions of pieces of data set, the decisions made automatically.
Well, I mean, it's not inline really. If you've still got an operator involved in it, we're going to try and take them out of it. But I would say, but Michael, looking at the applications of X-ray, there's certainly been a growth in semiconductor X-ray test. Do you think that's another area that's going to become mainstream for inline X-ray in the future?
Yeah, there are two kind of directions. One is to look for that elusive zero defect and be able to identify, for example, from a semiconductor, what are the patterns of instance of defects am I getting? Is it a certain part of the wafer that's providing that, or is it something to do with the packaging or bonding? And so there's a lot of emphasis on the discovery of the causes of those things and making sure that they can be filtered out. But then you come along to some of the more quite simple things like anti-counterfeit. You get a little black package with leads coming out and everybody thinks, yeah, that's my IC, that's great. No, it's just a bit of plastic actually, sorry. And we see X-ray being used quite extensively now to confirm that components are really what they say they are. Right. It's a thing that nobody really wants to admit, but most companies, if not all companies, have an issue with counterfeit, whether they know it or admit it. The US military, as we know, they've said 15% of their entire supply chain is suspect counterfeit. Right. So,
it's frightening, isn't it?
X-ray is a wonderful way to expose those kind of things, and in the same process, confirm the quality. Right. So you're doing two things with one piece of equipment. So that's quite cost-effective, actually, and it automates that process.
Is that something that's on your horizon, CK? The counterfeit market. Are you doing much on that side?
Yeah, it's basically the inspection is as Lu said, the process control, and after process control, we need to verify the production itself is well done or not. without inspection and last stage, we cannot verify anything. We can control the process, but without final inspection, we cannot guarantee any perfection of the product. That's the important point.
Right. Okay. Okay. So we're running out of time a little bit, but what is your view on the counterfeit side? Do you do much on that at all?
Yeah, it's a significant part of our business today, and has been for some period of time. So, yeah, it's definitely a market we see, and I think it's a fair point. Is if you can get a what we call a 2-for. So a lot of the counterfeit we work today is at an end product stage, or what we call final assembly and test. So again, you can verify the semiconductor device via either inline X-ray or island of automation X-ray. You can verify individual critical components like battery, where a fair amount of our business lands today, or a power hybrid device where there's a significant growth today. So all the way ahead of the printed circuit card. Then printed circuit board assembly is as well explained by CK. And then post printed circuit board assembly is final assembly and test. And here, if a product is coming into, for example, a repair center, you want to make sure before you're the manufacturer, you fulfill that warranty, that it really is the product they claim and that the defect is real. So that's a good example of where fraud detection is being used today. But also in that same environment, you can use the same setup, if you will, to verify things and find missing screws in a final assembly, loose screws, springs that are misaligned, things that would negate all of the value add in the previous steps.
Is that not a visual inspection tool rather than using X-ray to do that?
It's X-ray. A lot of times the device is fully packaged at that point, and anything other than X-ray inspection would be impossible unless you wanted to disassemble the product.
Okay.
I mean, in many cases, we're doing this fraud detection with the product still in the box. So it's still in the manufacturer's box.
Yeah.
Right. Fascinating discussion. I wish we had more time to go through to go into it, but unfortunately we've run out of time, gentlemen. So I want to thank the panel: Michael Ford from Aegis on the end, CK Park from Tech Valley in Korea, and Greg Wood from Nordson Matrix. Thank you, gentlemen.
Thank you.
And thank you for joining us today.
Thank you.